First guy, everybody had a homework. I mean, not that homework, but the math worksheet.
So.
How was it?
Good.
One too bad? Was it alright?
So good.
Okay. We'll go over the answers real quick. I don't want to dive too deep into it again, guys. Let me stress. When I tell you about logarithms and decimals, please know you may get 1 or 2 questions on the registry about logarithms and decimals, okay? It's not something that I want you guys to be so invested in, you know? That's why I gave you the paper. I want you to know that paper that I gave you so you have a broader general understanding. I don't want you guys to focus on, when you studying, to be looking at logarithms and decimals the whole time, you know? Because there's so much information in this chapter that we haven't even touched yet. You know, that's way more important to ultrasound production than what we're doing right now, okay? So, let's go over it so you can understand. I kind of even ask my questions the way I may ask them on the test, all right? What you about to say? I'm sorry.
Can you pull that up, the exercise?
Man, I don't even let me see, I don't even know where I put it at. I saved it somewhere, and I just made it. I made that in like 10 minutes the other day. I made it in like 10 minutes the other day. So, because I do have the, oh my goodness, I may have to pull it up. Do I have it? Oh my goodness.
You want it?
Nah, I'm gonna find it real quick. Where do I have it? Is it under JT Handouts? JT Handout, let's see. What was the name of it?
Logarithm and decimal worksheet.
Logs and decimals. There it is right there. Logs and decimals worksheet. Man, already, the answers are already on there, guys. The answers are already
That's fine. We need to understand.
We're good right there?
Yeah.
Good size. Okay, first question, guys. A 6 decibel gain would indicate what change in intensity? Meaning, already know we're talking about gain, right? So we know that that's, first we want to establish whether the decibel is going to be positive or negative. If I don't say it's negative, or if I don't say attenuation, we're going to assume that it's positive, okay? Well, anytime we're talking about ultrasound, we're always talking about attenuation. We know sound, as it travels, it gets weaker. So we always going to associate ultrasound as far as attenuation with being a negative decibel. Okay. All right, so a 6 decibel gain would indicate what change in intensity. I didn't have it. No kind of surprise effect, right? But 4-fold, right? Because we know that a 3 decibel change would be a half. It would double. It would double. 2 times 2, the next increment of 3 would be 6. That would mean it would be four times larger, or if it's an attenuated factor, then it's going to be 1/4 smaller. Okay, but in this case, I'm telling you a 6 decibel gain would indicate what change in intensity? A 4-fold increase. Okay, everybody got that one right? The multiple choice one was pretty easy. I'm sorry about that. Palmer's on it. Okay, number 2. If the equipment operator, and the reason I choose these words right here, because you never know how the registry is going to ask you. Just like I was using acoustic velocity for propagation speed, you never know how they're not going to just come with straight terminology out of the book. You have to know what these words mean generally. Okay, so the equipment operator or the sonographer decrease their transmit power. Already we know we're going to have a negative one, right? So by 18 decibels, the new intensity would be
64.
1/64th of the original intensity. Guys, are we good there? We understand that? Everybody, I want to.
No, explain.
Okay, so we already know that is going to be a negative decibel. So let's do our 3s, guys. Our 3, and we're just going to 3, 6. Now, however you guys do it, I'm just going to do it the long way. I know you guys probably have a better system than I do. 12. 15, 18. So we already know we're talking about negative decibels, right? Because we're talking about a decrease in transmit power by 18 decibels. The new intensity, like if I didn't give you a number, then you probably wouldn't be able to to figure that out. Like maybe if I didn't have it in multiple choice, you guys probably been like, man, what's that answer? What is he looking for, right? So that's why I put it in multiple choice, so you'll know if I have a quiz. I'd answer that. You know what I mean?
Right today.
So, definitely not today, because I'm letting you guys get out of it. So, we know we're talking about a negative. So, we know 3 is what? A negative 3 is going to be
One half.
It's going to be half. It's going to be half. So we're talking about, we already know we're talking about a decrease in transmit power. All right, because I'm telling you right there, that's the first thing you want to figure out. So we know that's going to be associated with 1/2 times 1/2, right here. 1/2 times 1/2
1/4.
equals 1/4. So on, 1/2 times 1/2 times 1/2 will equal 1/8. That's down right here. 1/2 times 1/16, right there.
132.
132.
164.
1/64, right there. So if you like, even if you gotta make this on your test, guys, even if you gotta write your increments of 3 on your exam, mine, I know I taught you that brain dumping was something that shouldn't be done, right? But I'm not gonna lie, it's a tactic I use all the time, because if it's something that I'm not sure about, let me get that information out right now. You know what I mean? Because all the other stuff I may know. Okay? So this is how we got to the 1/64th right here. Okay? And then if you just think about it, say for instance, you know, 1/6. I mean, let me see. We talking about 20 decibels is what, guys? 20 decibels is what? 100. And that's how I kind of think of the big number, right? 1/100. The negative 20 is 1/100. I kind of think of it like that. If I know it's 20, a negative 20 decibels, which is what is, you know, it's asking me for negative 18. What's the closest one to 100? Or 100, right? That's how I'm kind of looking at that. You know, if I'm just, you guys, if you know me, I always try to just break down stuff to the simplest form, logic based. You know, 18 is almost 20. We know 20 means 1/100. What's the closest one to that? Like the other ones almost don't even make sense to me. You know what I mean? So, but this is the way, if you have to do it the long way, this is the way I kind of want you guys to do it right there. Okay? Pat, we're good? We're good? Okay, we can work on it when we after class or something like that. Okay? Number 3, if the initial amplifier gain was 50 decibels and it was reduced by 1/2, the new amplifier gain would be, it's kind of tricky, right? And how many people got tricked? How many people got that right the first time? How many people got it right the first time?
It was 50.
So that means my initial intensity was at 50 decibels, right? It's telling us that it was reduced by 1/2. Okay, we know that 3 decibels are, you know, or negative 3 would be 1/2, right? Because that's what the 3 is, right? So you're just going to take 3 away from the initial intensity. Okay. All right. So it's not taking away 25 decibels, because that would be more than 100 times smaller, correct? Because we know 20, if we take away 20 decibels, we already know that's 100 times, or negative 20 decibels, that's 100 times smaller. It's only telling us it's reduced by 1/2. We know that negative 3 means 1/2 up here. Okay? So we're just going to take 3 away from the initial intensity. So it's going to be 47. I threw that in there on purpose because I wanted you guys, because like I said, you never know how I'm going to ask these questions. I really made this right here similar to how I'm going to ask questions, but at the same time, I want you guys to understand that you already know this information. You know what 1/2, you know what 1/2 is. That's negative 3 decibels. We're good, guys? We're good? Everybody? Sweet, get Lauren? 100? Hadley? We're good? All right. This one right here, let's say I do have calculators for you guys, for my people that need calculators for the next exam. If I happen to have math like this on there, I don't want you to be doing our division in the long format, even though that's what it requires, right? So, if the initial intensity of a pulse was 100 milliwatts per centimeter squared, what is the reflected signal intensity if it is attenuated 9 decibels? So, first, we already know when we're talking about attenuation. What is that?
Want some water?
We already know. I'll be fine, dude.
I got a whole new bottle here.
If I need it, I'm gonna give it to you. So we just have to figure out, we know it's talking about attenuation of 9 decibels. So we know that it's gonna be associated with a negative decibel, correct? All right, so luckily we already have that on the board right there. We know a negative 9 decibels is equivalent to 1/8, okay? So what we're gonna have to do here is cross multiply, correct? Cross multiply. So let's take our 100 100 over 1 times 1/8 equals
50 over 4.
equals 100 over 8. Somebody pull their calculators out for me.
4.5.
12.5 milliwatts per centimeter equals 12.5. I'm just gonna leave it without the
So when it
remember the
attenuates, we
Came out
divide.
like
When
this.
it when it strengthens, we multiply.
That's still multiplying.
I'm still multiplying right
That's
here.
still
Still multiplying. Still multiplying.
Oh,
I'm still multiplying.
Yes, multiplying.
We're always gonna multiply no matter whether you're attenuating or not. You're always gonna multiply. Always gonna. Okay? It's just it's easier to do it when it's a positive decibel. That's why I threw that on there, so you'll know how to do it at the same time when it's negative. Okay? Alright guys, the next one. Easy breezy, right? The log of 1,000 is equal to what, guys?
3.
3. Just count your zeros.
Yeah.
Just count how many zeros here. 1, 2, 3. That's the log right there. That's the log right there. So if I had 1,000,000, that log would be 6. Take 6 zeros to make 1,000,000. Okay? That's meant to be super simple. Super simple. I hope it was. I don't want to say it was, but I hope it was. Okay? We're good there, guys? Okay, good. Boom. Number 6. A sound beam has been attenuated by 70 decibels. Attenuated by 70 decibels will be blank of its initial intensity. Because you knew how to answer number 2, that's why I left this one without multiple choice, because you already kind of knew what I was expecting. Which is, that's again, if you know the number 7 is telling you how many zeros it's going to be right when we're talking about decibels. Okay, so that's going to be what, guys? We're talking about attenuation, so we know that's going to be associated with a negative decibel or a number less than 1. Okay, that's going to be 1 over 10 million. Okay, 1/10,000,000th of the initial intensity. Okay. Mike? Okay. We're good, guys?
So anytime you say attenuation, then automatically we have to know it's negative.
Absolutely.
Because you don't have to put another negative in
I don't
front
have to
of the
put the
number.
negative sign. If I say a decrease in intensity, you know that's going to be associated with a negative decibel as well. Okay. So definitely, guys, I want you to be more careful in reading your questions. Read your questions very carefully. Yes, ma'am.
How are you going to multiply on 4 and subtract on 3?
Subtract on 3.
Yeah.
Oh, because it's all about number 3 is telling you already what it's reduced by. It's telling you it's reduced by half.
Yeah.
By half. We know that a 3 decibel change will be either positive 3 decibel will be it double, negative 3 decibels meaning it's gonna be in half. So I know because it's giving me the initial intensity. I'm just gonna take 3 from the initial intensity because it's already giving me that factor. The number 4 is telling me what would the reflected signal be if it attenuated 9 decibels. So I have to know what 9 decibels is, and cross multiply by that number. I mean, not cross multiply, but multiply it by that number. Not cross multiply. But stay with me, because I'm really trying to get to the lesson today. I really have to get to it. But stay after class and I'll explain it to you even more in depth. Even more in depth. Guys, anybody get it 100? Anybody get it 100? Nice. It's not a grade, but it's still nice. It's still nice. That's just for you guys, my gold people in here who wanted that association. There you go. I worked very hard on these questions. All right, guys. Boom. All right, so we already started this chapter talking about logarithms, how ultrasound production, logarithms, decibels. We talked about attenuation, what attenuation was, and the 2 factors that that kind of determine attenuation are right here. Okay, remember path length and the frequency of sound. Both of those directly related to attenuation. Okay, that means if I have to travel deeper into the body, that's what path length is. As I'm going deeper, that means my sound is going to be attenuated more. Okay, if my frequency is higher, this frequency right here is going to be attenuated more than this